Hello students, now we will discuss about solar radiation. Solar radiation. The intensity of solar radiation keeps on attenuating as it propagates away from the surface of the earth. Though the wavelengths remain unchanged, solar radiation incident on the outer atmosphere of the earth is also known as extraterrestrial radiation. The extraterrestrial radiation deviates from solar constant value due to two reasons. The first one is the variation in the radiation emitted by the sun itself. The variation due to this reason is less than plus or minus 1.5% with different periodics. The second one is the variation of the Earth-Sun distance arising from its slightly elliptic path. The variation due to this reason is plus or minus 3% and is given by the below expression. IEXT is equal to ISE 1 plus 0.033 cos of 360 N divided by 365 W per meter square. The extraterrestrial radiation being outside the atmosphere is not affected by the changes in atmospheric conditions. While passing through the atmosphere, it is subjected to mechanisms of atmospheric absorption and scattering depending on atmospheric conditions, depleting its intensity. A fraction of scattered radiation is reflected back to space while remaining is directed downwards. Solar radiation that reaches Earth's surface after passing through the Earth's atmosphere is known as terrestrial radiation. The terrestrial radiation expressed as energy per unit time per unit area is known as solar irradiation. The term solar isolation is defined as solar radiation energy received on a given surface area in a given time. The positions of extraterrestrial and terrestrial regions are indicated in the figure below. This is the propagation of solar radiation through the atmosphere. Depletion of solar radiation. The Earth's atmosphere contains various gaseous constituents, suspended dust and other minute solid and liquid particulate matter. These are air molecules, ozone, oxygen, nitrogen, carbon dioxide, carbon monoxide, water vapor, dust and water droplets. Therefore, solar radiation is depleted during its passage through the atmosphere. Different molecules do different things as explained below. Absorption. The absorbed radiation increases the energy of the absorbing molecules, thus raising their temperatures. Nitrogen, molecular oxygen and other atmospheric gases absorb the X-rays and extreme ultraviolet radiations. Ozone absorbs a significant amount of ultraviolet radiation in the range 1 is less than 0.38 micrometer. Water vapor, H2O and carbon dioxide absorb almost completely the infrared radiation in the range of 1 greater than 2.3 micrometer and deplete to some extent the near infrared radiation below this range. Dust particles and air molecules also absorb a part of solar radiant energy irrespective of wavelength. Scattering. Scattering by dust particles and air molecules involves redistribution of incident energy. A part of scattered radiation is lost to space while remaining is directed downwards to the Earth's surface from different directions as diffused radiation. In scattered sunlight that makes the sky blue. In cloudy atmosphere, a major part of the incoming solar radiation is reflected back into the atmosphere by the clouds. Another part is absorbed by the clouds and the rest is transmitted downward to the Earth's surface as diffuse radiation. The energy is reflected back to the space by reflection from clouds plus scattering by the atmospheric gases and dust particles plus the reflection from the Earth's surface is also called the albedo of its atmosphere system and has a value of about 30% of the incoming solar radiation from the Earth as a whole. Thus, on the surface of Earth, we have two components of solar radiation: direct or beam radiation unchanged in direction and diffuse radiation, the direction of which is changed by scattering and reflection. Total radiation at any location on the surface of Earth is the sum of beam radiation and diffuse radiation, what is known as global radiation. These terms may be properly defined as follows. Beam radiation. Solar radiation propagating in a straight line and received at the Earth's surface without change of direction, that is, in line with Sun, is called beam or direct radiation. Diffuse radiation. Solar radiation scattered by aerosols, dust and molecules is also known as diffuse radiation. It does not have a unique direction. Global radiation. The sum of beam and diffuse radiation is referred to as total or global radiation. Measurement of solar radiation. Solar radiation data are measured mainly by the following instruments: pyranometer, pyrheliometer. Pyranometer is designed to measure global radiation usually on a horizontal surface but can also be used on the inclined surface. Pyrheliometer, an instrument that measures beam radiation by using a long and narrow tube to collect only beam radiation from the sun at normal incidence. Sunshine recorder measures the sunshine hours in a day. Pyranometer. A precision pyranometer contains a thermopile whose sensitive surface responds to radiation of all wavelengths and hence measures accurately the total power in the instant on it. It consists of circular black end, hot junctions exposed to the sun and cold junctions are completely shaded. The temperature difference between the hot and cold junctions is the function of radiation falling on the sensitive surface. The sensing element is covered by two concentric hemispherical glass domes to shield it from wind and rain. This also reduces the convection currents. The instrument has a voltage output of approximately 9 microvolts and has an output impedance of 650 watt. The pyranometer, when provided with a shadow band to prevent beam radiation from reaching the sensing element, measures the diffuse radiation only. Many inexpensive instruments are also available for measuring light intensity, including instruments based on cadmium sulfide photocells and silicon photodiodes. These instruments give good indication of relative intensity, but their spectral response is not linear and thus cannot be accurately calibrated. Pyrheliometer. The normal incident pyrheliometer uses a long collimator tube to collect beam radiation whose field of view is limited to a solid angle of 5.5 degree by approximate diaphragms inside the tube. The inside of the tube is blackened to observe any radiation incident at angles outside the collection solid angle. At the base of the tube, a wire wound thermopile having a sensitivity of approximately 8 millivolt per meter square. The tube is sealed with dry air to eliminate absorption of beam radiation within the tube by water vapor. A tracker is needed if continuous readings are desired. Sunshine recorder measures the duration in hours of bright sunshine during the course of the day. It consists of glass sphere mounted on its axis parallel to that of Earth within a spherical selection bowl. The bowl and glass sphere is arranged in such a way that sun's rays are focused sharply at a spot on a cord held in groove in the bowl. The cord is prepared from special paper bearing a time scale as the sun moves. The focused bright sunlight burns a path along this paper. The length of the trace thus obtained on the paper is the measure of the duration of the bright sunshine. 3 overlapping pairs of grooves are provided in the sphere segment to take care of different seasons of the year. Thank you, students.